What do this burning candle wick, this board being cut into pieces, this ground being tilled up, this egg being cooked, these plants using the sun's energy to grow, and the food being turned into energy by your body, all have in common? The answer is that all these things involve changes in matter. Matter does not always stay the same. In fact, almost all matter is changing. We often think of matter, such as rocks in this mountain, as not changing. But over many years, the rocks gradually break down through the action of water, ice, plants, and wind. But in other examples, such as in the fracturing of this rock, it is easy to see the change in matter. During the next few minutes, we are going to study the different ways matter changes. What changes occur when this ice cube is crushed with these pliers? As you can see, the ice breaks into many small pieces of ice. This is a block of clay. It is soft and can be shaped into something different, like this turtle. And these chopsticks used to eat food were shaped from trees like these. All these materials have gone through a change, a physical change. A physical change is a change in the size, shape, or phase of matter without the matter changing chemically. Let's look at some more examples of physical changes. When relatively cold, the water in these icicles is frozen rock solid. But as the temperature warms, the ice gradually changes to a liquid, forming these liquid drops of water. The water changed phase from a solid to a liquid, but still remains water. Temperature can play a big role in physical changes. Temperature can also affect the size of objects. For example, this metal lid expands when exposed to hot water, thus making it easier to loosen. And this bicycle tire contracts or gets smaller when the temperature decreases. This can be seen easily in a thermometer. When the temperature increases, it causes the liquid in the thermometer to expand and then rise. But when placed in ice water, the red liquid contracts and then drops. Another example of a physical change involves water. Water at room temperature is a liquid. When the water is placed outdoors on a cold winter day where the temperature is below 0 degrees centigrade, it changes to its solid phase, or ice. And if the water were to change to steam or gas, it changes its phase, but still exists as water. In a physical change, matter can also change its shape. For example, these branches are long and thick, but when placed in this chipper, they get ground into small pieces of wood. The wood chips come from the wooden branches that were changed physically into smaller pieces of wood. Their shape has been changed. We have studied some examples of physical changes, including changes in size, phase, and shape. Now let's explore other changes in matter, chemical changes. In physical changes, you have the same material before and after the change. For example, with paper, we have a large piece of paper that can be torn into many small pieces, a physical change. Even though the appearance of the paper has changed, it is still paper. This is a physical change. In other words, the chemical properties of the paper have not changed. A chemical property is the way to describe how matter reacts with other matter. The paper we have just torn up, for example, can burn easily if we light it with the match. The ability to burn is described by the chemical property called flammability. The paper went through a chemical change. How do we know this? One way we know that a chemical change is occurring is that we can see it. Before the change, the paper looked white, but after the change, it was black. Another clue that a chemical change occurred is that heat is given off. We can feel the warmth from the burning paper. To make absolutely sure that a chemical change occurred, we could study the chemical makeup of the paper in a laboratory using special equipment before and after the reaction. This would show that the white paper has a different chemistry from the ashes after burning it. A chemical change is defined as the process by which a certain substance becomes a different substance. Let's take a look at another chemical change. This is a chemical called iodine. We will put a few drops of it on this piece of potato. Notice the color change. The potato has something in it called starch, which creates a chemical reaction with the iodine. We can see the results of the chemical reaction by the color change. Here are some points that determine if a chemical change has occurred. In chemical changes, a new substance is formed. In chemical changes such as the cooking of this egg, a color change occurs on the outside of the egg from clear to white. Sometimes in chemical changes, as in the case of the burning flare, heat and/or light is given off. And in some chemical changes, such as when this tablet is placed in water, bubbles form, which is another clue that a chemical reaction may have occurred. Now let's see how good you are at identifying physical and chemical changes by observing the characteristics of some different changes in matter. In this change, the chainsaw produced tiny particles of wood called sawdust. Is this a physical or chemical change? This is a physical change that merely changes the size of the wood. Electricity is flowing from this battery through the wire to the bulb, causing it to light. Is this a physical or a chemical change? This is a chemical change. Both heat and light are given off. What about mixing sugar and powdered fruit drink together in water? Is this a physical or chemical change? This is a little tricky. It is a physical change. Even though you can no longer see the sugar and fruit punch in the water, the sugar and fruit drink did not change chemically. Try identifying physical and chemical changes in your house or school. With some more practice, you will get quite good at identifying the different types of changes. Chemical changes occur at different speeds. Some chemical changes occur very quickly and are quite noticeable, while some are very slow and can only be noticed over long periods of time. The process of rusting is an example of a slow chemical change. When iron reacts with oxygen in the air, it gradually corrodes, forming a new substance. The process of iron reacting with oxygen is a type of chemical reaction. This process can take months or years and is marked by this orange color. Decomposition is another slow chemical change. Most things that were once living decompose or break down. This is a relatively slow process. Other things, such as these cans and bottles, take years to decompose and can remain here on this beach for a very long time. While some chemical changes occur slowly, others occur quickly, such as the burning of these logs. Many chemical changes in our bodies occur in a fraction of a second. Every time you move, a chemical reaction occurs. The exploding of these chemicals in these drill holes occurs almost instantly when ignited by an electric charge.
Fire in the hole.
Okay, you got it?
As we have already seen, there are many different types of chemical changes. A chemical reaction is a chemical change in which one or more substances is changed. Let's look at some examples of chemical reactions. These two substances might be found in your kitchen at home: baking soda and vinegar. Another word for baking soda is sodium bicarbonate, and another word for vinegar is acetic acid. When acetic acid is added to sodium bicarbonate, a chemical reaction occurs. You can see the bubbles, and you can even hear the mixture fizzing. We can symbolize or write out the chemical reaction. The reaction started with sodium bicarbonate and acetic acid. When the two are mixed together, new substances are formed. These new substances are called sodium acetate, carbon dioxide gas, which you can hear fizzing, and water. Another very important reaction that takes place occurs in plants. You may have heard of the reaction called photosynthesis. In this reaction, plants breathe in the gas called carbon dioxide through their leaves and also take in water through their roots. Using the sun's energy, a chemical reaction takes place that produces oxygen gas and energy. This reaction can be written like this, where carbon dioxide and water reacts with the sun's energy to form oxygen and water and energy. During the past few minutes, we have explored physical changes in matter, as well as chemical changes in matter. And we have learned how to identify physical and chemical changes. Next time you get a chance, try to identify physical and chemical changes in your school, neighborhood, and home. You will be amazed at all the changes in matter around you. Fill in the correct word when you hear this tone. Good luck, and let's get started. 1. Ice being broken into small bits is an example of a change. 2. In a physical change, the matter does not change. 3. In a chemical change, a substance is formed. 4. A chemical is a way to describe how matter reacts with other matter. 5. Flammability is the chemical property describing how a substance . 6. A clue that a chemical change is occurring in a burning flame is that is given off. 7. Chemical changes occur at speeds. 8. Is the substance produced by iron reacting with oxygen in the air? 9. A chemical is the chemical change in which one or more substances change. 10. Is a chemical reaction in green plants that produces energy and oxygen.